Hi everyone, welcome back to our YouTube channel. This is Clarice Lim. Today I'm going to go through P4 Science Review States of Matter, or just simply matter. So what is matter? Matter is anything that has mass and occupies space. Okay, so it includes a lot of many things. In fact, many things around us has mass and occupies space. Even the air around us has mass and it does occupy space. How is that possible? Okay, we will explain that later. But in order to understand matter better, it will be easier for you to imagine what is non-matter. Because if everything is matter, what is not matter? Okay, so what is not matter? For example, light. For example, heat. For example, sound. So you might be very familiar with all this because they are all a form of energy, isn't it? Okay, so heat is a form of energy. If you have heat going on, if you have light going on, or if you have sound going on, you are not you will not be hindered by the fact that they're around and you cannot enter the same space as them because they do not occupy space. That's why they are non-matter and they do not have weight. They don't weigh on you. Okay, the energy might be able to do something to you, but they do not weigh on you. They do not have mass. Okay, so if you see a shadow or if you see light, the sun is shining on us, there's light. When there's sun shining on us, it doesn't mean we cannot occupy the same space. We can. Okay, so which means that light, heat and sound does not occupy space. They do not have mass. They do not hinder us in any way. They are a form of energy. They are completely different. They are non-matter. So what is matter then? Matter can be compared by looking at their differences and similarities. For example, you can compare them in size, you can compare them in shape, in mass, in texture, in color, in material, in hardness. Basically things that you can see, things that you can touch. Can you then touch air around us? You can. Just by fanning like this, you can actually feel that there's wind going on. So if you can feel it, there is a wind going on, which means you are moving something that is in this invisible environment, which is a form of gas actually. So what is gas? Gas is actually one of the state of matter. There is three states of matter. There is solid, liquid, and gas. So what is this gas? Why is it all around us? Because gas basically is something that doesn't have a fixed shape, doesn't have a fixed volume. It can fill up the entire space that you put it into. Okay, it doesn't have a fixed volume. So if you put it in a small container like this is the volume of gas. But if you put the same amount of gas, you enlarge the volume of the container, the gas will fill up this entire container. The only thing about them is that the mass stays the same. Okay, because gas is a form of matter. Matter occupies space and has mass, correct? So it is a form of matter. So these particles you see inside, they are the same amount, which means the mass that they have, the mass that they possess is the same. Okay, so if you put them in a small area like this, it is the same mass. If you put them in a big area like this, it is still the same mass. The volume changed, the mass do not change, because mass basically means the amount of matter inside it. Okay, so it's written over here, mass is equals to the amount of matter a thing has, which is this small little thing. You can call them atoms, you can call them particles, up to you. P4 level, you don't need to know exactly what they are, you just need to call them matter. So the volume is the amount of space that thing occupies. Then what about solid and liquid? Solids has fixed shape. Like for example, a mouse. Okay, the mouse is fixed shape. No matter where you put it, it is still a mouse. It doesn't melt and dissolve and become something else. Liquid does. Okay, so the liquid, you can put them in a container and it takes the form of a container. If you put them in a bigger container, they will become less because the volume is the same, but they will continue to take the shape of the container. What do I mean? If you look at this over here, you will notice. So the solid, you put it in a container, it stays the same. The shape doesn't change, just like a mouse. Okay, the shape stays the same. It is rigid, it has a fixed shape, it has fixed volume, and you cannot squash it. You cannot squash it, meaning you cannot make the volume smaller. Okay, but can you change the shape? Of course you can, like plasticine. It is a solid because if you put the plasticine inside the container, the plasticine stays the same until when you squash it. But Mrs. Wee, you said solids cannot be squashed. Not the same kind of squash. Okay, when you squash it, as in literally you press it down, the shape changes, correct? But the volume of the plasticine stays the same. in science, when we say it can be compressed in terms of the gas, gas can be squashed, gas can be compressed, it means the volume literally changes. But when you compress solid, the volume doesn't change. You notice if you squash the plasticine, if it's a ball, you squash it, the sides changes, the sides leak out, okay? Which means this whole volume, this whole solid actually needs to take up the space of something else over here. It leaks out, which means the volume will essentially stay the same, which is why we say that solid cannot be compressed, it cannot be squashed, because the volume is always the same. No matter how you flatten it, the volume spreads out. The volume is the same. But in gas, it is not like that. Okay, you can literally put gas inside a syringe, you compress it, the volume changes, and you let it go, the volume changes, and you press it in again, the volume changes again. Okay, so that is the difference between solid and gas. What about liquid? Liquid, not rigid, it takes the shape of a container. There is no fixed shape. There is fixed volume though, okay? There is fixed volume. It cannot suddenly increase. If you put it in a big container, you get more water. If you put it in a small container, you get less water. No, it doesn't work that way. Gas, yes. Liquid, no. So liquid and solid, fixed volume. It doesn't change according to container. It does not. Okay, but the shape does. Okay, liquid takes the shape of the container, remember that, so it is not rigid, which is why you look at it in terms of the atoms way, in terms of the particles. Solid is closely packed. There's no way you can move them unless you give them energy, unless it's like, for example, you imagine the ice cube. So ice cube is a square, right? Correct? It's a fixed shape. It has a fixed shape, it has a fixed volume, it is closely packed. If you give it energy, you boil it, and then the particles start to move. They bounce against each other, and they gain a lot of energy from the heat, and they scatter out. They become loosely packed, like liquid. But is it the same amount of them? Yes, it's the same amount of them. But do they have fixed shape? They do not have fixed shape. They're moving around already. Okay, but can you compress them and reduce their volume just because you put them into a smaller container? No, you cannot. Their volume do not change. It is still the same amount of them. But if you continue to boil them further, what happens? You continue to boil them further, you give them more energy, they will vibrate even more, bounce against each other, and they whoo, and then they go flying up. They become gas. You give them so much energy, they separate out, they fly out all over. And if you put them into a bigger container, they will be able to fly out all over. But the same amount of them is inside. The mass doesn't change. The volume changed in gas. Okay, you'll be doing a lot of all these experiments in school, so I don't need to show you them here. Okay, but I'll show you some questions on how you can answer them instead. Right, so Jermaine and her friends were at the beach building a sandcastle. She filled a bucket with sand to the brim. When she poured some seawater into the bucket to wet the sand, she noticed that the seawater did not spill out. Oh, it's a whole bucket of sand. Why is it that the water can still go in? What is the reason? The reason is because the sand is filled. The sand is a solid shape. They are small little cubes, right? They're small little cubes. You can imagine them small little cubes. So between the cubes, they actually have space. They can't completely fill up every single part of the space inside the pail. So what happens is, because there is small little holes inside them, when you pour the water in, because water has no fixed shape, water goes in, water fills up all these little gaps in between the sand grains. And therefore, when water fills up all these sand grains, space between the sand grains, water continues to go in and fill up this space. Nothing needs to come out. Isn't it? Nothing needs to come out. So how do you explain that then? That seawater did not spill out from the bucket, exactly what I said just now. So there are still spaces in between the grains of sand, therefore filling up the space. You see? So there are still spaces in between the sand particles which the seawater entered to displace the air in it. Displace means it pushes out the air, which is why when you pour water in, you will actually see some air bubbles coming up. Those air bubbles are from the space in between the sand grains. Okay? So this is how you explain what is the keyword. The key will be that spaces, the spaces. Okay, and the seawater entered to displace. If you can remember this word, displace, because all matters occupy space, all matters has mass. When they occupy space, the other word that you can use to represent the taking over of the space will be the word displace. Okay, so displace will be a very important keyword you will need to use in answering matter questions. Okay, remember this keyword. So there's spaces in between, and the seawater entered to displace the air inside it. This is how you explain this question. Then Jermaine used another bucket to collect seashells to decorate the sandcastle. So another bucket full of seashells. So she could only put 50 seashells in a bucket. Why is that so? Okay, remember, what did you learn in matter? You learned that matter has got 3 states: solid, liquid, and gas. Seashells are solid. So why is it that she can only put 50 seashells and nothing more? Basically because seashells are solids, right? They have solids, they have fixed shape, and therefore they have fixed volume. If you put 50 inside and it's full, it is 50 inside. You cannot put any more things inside. Okay, it might seem like very obvious because the 50 seashells is filled the bucket ready so how do I explain? So you might write things like because the bucket is full. Remember, in science paper, if you write the obvious answers without any scientific concept that you have learned or any keywords inside that you have learned in the answer, you will not get a single mark. Okay, of course, everybody knows that the bucket is full, so you can't put any more inside, right? But what is the keyword? The keyword is that solids, this is what you have learned in science, okay, and they have fixed shape and fixed volume. This is what you have learned in this topic. Okay, so these are the keywords you need to have in your answer. If not, you're going to get 0. Okay, remember these keywords. Gary wanted to find out the volume of object K. Therefore, this is the displacement can experiment. He used the displacement can. What is displacement can? In displacement can experiments, basically what they do is they fill the water up all the way to the level where the hole is over here. Okay, why is that so? Because if you want to measure the shape, the volume of this irregularly shaped item, you put it in. Because all matter occupies space, this is solid, this is a liquid. So this solid will displace the water in this container, therefore displacing the volume of water here using the exact volume of the item here. I say again, the volume of object K will completely replace the same amount of volume of water from here. And this volume of water is displaced to where? They do not just disappear. They are not gas. Okay, their volume is fixed. So where do they go? This same volume of water will flow out into the measuring cylinder. Therefore, the amount of water that flowed out as a result of you putting object K inside will be the exact volume of object K. Okay, so this is how you can use the displacement can. So in this experiment, there is a little bit of volume poking out over here. Object K is not completely submerged, which means this volume that is poking out did not replace a single extra drop of water inside. Okay, the water that is inside is only displaced by this part of the volume, not this poking out part. Okay, so which means this poking out part, the volume of this poking out part is not measured. It did not displace any water. So Gary concluded that the water volume of object K is 50 ml because it's shown here. You might not be able to see, but it's over here, 50 ml. As shown in the measuring cylinder, do you agree that the volume of K was 50? No, of course not, as what I've explained to you, because object K is not fully submerged. Okay? So, no, the answer is no. Object K is not fully submerged in water. Hence, its volume is more than 50. Okay, so what's the keyword here? It is not fully submerged. If you want to be a little bit more careful, you can actually say there is a volume of the K that is not displacing the water. Therefore, the volume of 50 ml does not fully represent the entire volume of object K. Okay, that will be a little bit more technical. You can do that too. So this one, City used a level balance to find out the mass of some books as shown in the diagram below. Okay, so there's some books over here, there is some fixed mass over here, and she recorded a height B and height A. City recorded a change in the heights when a fixed mass is added to the balance each time. So she slowly adds the weight over here and the height changes like a balance, right? Okay, so the heavier it is on the fixed mass, the higher the books go. this way. So the fixed mass, when it reaches 50, when it is 50 over here, the height is A, which means the book is still heavier, correct? And the height of B is 17. So 50 is not enough to balance the book. What happens when it reaches equilibrium? If Lily adds more mass over here, the height B will decrease and height A will go up. So what happens when it reaches equivalent? This is how a balance works. When it is equilibrium, when it is equal to each other at equal height, it will mean that they are the same weight. Okay, I say again, when it is like that, this one is heavier, this one is lighter, correct? Where it is like that, this one is heavier, this is lighter. You play seesaw before, okay? So I hope this is familiar to you. But when you are like this, when both is at the same height, it means both has the same weight. Okay, so remember this, So therefore, over here in this book and this mass, okay, so when the mass is at 100, okay, initially it's like this, the book is heavier, the mass is at 100, it keeps dropping, okay, when it goes to 200, it drops some more, when it goes to 300, oops, now the books are no longer heavier, the mass is heavier now, okay, so and then you go some more 420, it goes all even more, so the books are definitely lighter than 300, because by the time 300, the weight is heavier, okay. But when it's 200, the mass is still lighter. The book is heavier. So which means the mass of the book is somewhere in between 200 and 300, isn't it? So how do you know what is the exact? The exact is like this. Okay, so because the question, why do I ask you that? Because the question says, based on the table above, what is the mass of the books likely to be? So which means you need to find the 10, 10. Why do I say 10, 10? Because when this is 3, this is 17, different. When it's 5, this is 15, different. When this is 8, this is 12, different. When this is 11, more than this, 9. You see that this is always more than A. This becomes more than B. So which means the balance between them is most likely 10 versus 10. Because why? It's in between. Correct? It's in between. When it's 10, 10 is in between. It can be 9, 9 also. Can it be 9, 9? No. Because when it is 9, this is 11. So it is not 9. It has to be 10, 10. Can it be 11, 11? No. Because when this is 11, this is 9. Right? Can it be 8? No. Can it be 12? No. You see? So it has to be 10. Only 10 is missing, right? So in order to reach 10, it will be 12 minus 2. It will be 8 plus 2. So every time there is plus 2, you see 3 to 5 is plus 2. 17 to 15 is minus 2. How much weight is added? 50. 100 minus 50 is 50. So for every 2 cm change, it has to be 50 gram. So in order from 8, a heavier book, to become a lighter book, is from 8 to 11, and we know the equilibrium point is 10. Therefore, you need a change of 2 cm, which means it will be 200 plus 50. Okay? If you don't understand what I'm saying, rewind the video, listen again. Okay? The answer is 200 plus 50 in order to get that 2 cm change. In order to get from 8 to 10, in order to get from 12 to 10, you need 2 cm change. Every 2 cm is 50 grams over here. Therefore, 200 plus 50 is 250. What is the mass of the books likely to be in order to achieve equilibrium? It has to be 250 grams. Then, Siti next placed a rubber ball at one end of the lever balance. She added some sand at the other end until the lever balance was balanced, as shown, right? Draw what she will observe of the lever balance after 200 centimeters cube of air was pumped into the rubber ball in the box below. Okay, so you're supposed to draw using this box over here. Let's take a look at this first. So you say that you are adding the rubber ball with air. Okay, what did you learn in air in this topic? You learned that air occupies space and has weight because they are all matter. Air is a form of gas. Gas, liquid, and solid, they are all matter. All matter occupies space and has weight, which means air has weight. So if you add air inside the ball, what will happen? Will it still be balanced? Will it still be the same weight? Just now I explained to you, if it's the same weight, they will balance, isn't it? But if you have more weight over here, they will no longer be balanced. So how will the balance look like? The balance should look like this. It will tilt down. Okay, maybe not that much because air is not that heavy, but it would definitely tilt downwards. So as long as you draw something that's tilting downwards towards the ball to show that you know that air has mass, then you will get the question correct. So then where is the volume of air in a rubber ball now? Okay, so the volume of air in a rubber ball is 100 centimeters cubed. No matter how much more you pump inside, the ball stays the same at 100 centimeters cubed because air has no fixed volume. It takes the volume of the container, and in this case, the container is 100 centimeters cubed. It is fully inflated, and no matter how much air you pump inside, air can be compressed, so they will not take up extra space. They will take the volume of the container. So therefore, the volume over here is still 100 centimeters cubed. Okay? That's the answer. Fatima took a piece of plasticine. Just now I mentioned plasticine, right? No matter how you mold, they are still solid. No matter how you compress, you change their shape, the volume is still the same. You cannot have this amount of plasticine. After you shape, it becomes like this. No, it cannot be. There will be remnants. Even if you flatten this ball of plasticine, you flatten it, it will be flat. This volume and this volume is still the same. Solids doesn't change volume. Okay, solids has fixed volume. So from this volume, change into this shape, and into this shape. Wow, amazing Fatima. She can make all these things out of a plasticine. So she measured the mass of each shape every time she has molded it and drew the bar graph below. Okay, so she drew the bar graph. Do you think the mass has changed? Remember, solids do not have variable mass, doesn't have variable volume. Therefore, they have fixed volume, fixed mass. They don't change. Therefore, how do you complete this bar graph over here? Obviously, they must all look the same. Don't worry, I mentioned this in one of the video, in my science video. Don't worry if there's no change. Just say no change, right? You just draw exactly, there's no change. There can be trick questions like that, so don't worry. So Fatima next took substance K and measured the volume. Okay, so she then tried to press substance K and measured its volume again. So what is substance K? Substance K is this one. Correct? This is the plasticine that she was playing with. So she recorded her findings in the table below. When it is pressed, when not pressed, the volume is 150. After it was pressed, it's still 150. What did I tell you? Okay, solid doesn't change in volume or mass. So from the table above, what can Fatima infer about the state of matter? That substance K is in. Therefore, the only one that does not change in a volume and doesn't take the shape of a container, you see that you can shape it into the exact shape that you want. So therefore, you cannot guess that substance K is liquid, even though it has fixed volume as well for liquid. But this one, it doesn't change into the shape of the container. Okay, therefore, it is a solid. So because solids have definite volume and volume do not change after compressing. So where are the keywords? The keywords obviously is solid. Okay, solids have definite volume. This is what you learn in this topic. And volume did not change after compressing, and therefore it is solid. These are the keywords you need for your answer. Next one over here. David placed an inflated basketball on a weighing scale as shown below. So he observed that the mass of the inflated basketball is 500 grams. So that's the mass. Remember, for mass, it doesn't change. Okay. The mass, even for air, it doesn't change. The only thing that changes is the volume, no fixed volume. So there is air inside. We're talking about air now, talking about gas. So David deflated the basketball and measured its mass. What will happen to the mass of the basketball? Will it be the same? No more, of course not. It will no longer be the same because the mass of the basketball now excludes the air. If it excludes the air, air takes up space. Air has mass. If you remove the air, the mass will drop. Okay, so therefore, how do you answer this question? You take out the air, the mass of the deflated basketball will be smaller, lighter than the mass of the inflated basketball. It will become lighter, basically. Okay, so the mass will be smaller, the mass will be lighter. That's the keyword. What does your answer in A tell you about the property of air? Air has mass, isn't it? What is the property of air that you know about? Okay, remember what you have learned in this topic. Air has mass, correct? So that is the answer. Air has mass. So the volume of the basketball is 800. Remember, volume doesn't change. So the volume is 800. There is 800 centimeters cube of air inside already. You pump in another 50 inside. What is the final volume of air in the basketball? It is still 800. Nothing changed. You have to remember that the volume of air takes the volume of the container. Volume does not change. Mass changes in gas. So what does your answer in part C tell us about the property of air? That air can be compressed because basically you pump in more, the volume doesn't change. How do you then pump in more? It just means that air can be compressed, isn't it? Okay, I hope you understand this topic well by now. I will see you in other videos. Subscribe and be notified of our new videos. See you soon. Bye-bye.